is Algebra 1, Lesson 3.5, Linear Equations and Problem Solving. We're going to draw diagrams to help understand these real-life problems so we can create algebraic equations to solve for variables beginning on page 160. The first example is visualizing a dog pen. The description you get is you have 112 feet of fencing to enclose a rectangular pen. So you need to understand the shape of a rectangle. You need to understand that you have 112 feet of fencing. That means you're not going to get more fencing. You're going to have 112 feet to get around the pen. So if you're talking about the distance around something or the distance to enclose this pen, you're talking about the perimeter. To provide sufficient running space for a dog to exercise, the pen is to be 3 times as long as it is wide. So you don't know how wide it's going to be. You don't know how long it's going to be. So anytime you represent something you don't know, you represent it with a variable. So an unknown amount is x, but it has to be 3 times as long as it is wide. So the same unknown x multiplied by 3 will give you the length. X will represent the width. So drawing the diagram of a pen shows that the length is 3 times its width. To find the dimensions, use the formula for the perimeter of a rectangle. We know what the formula for the perimeter is. Perimeter is the distance all the way around. It's length plus width, or 2 times the length plus 2 times the width. That's a formula you're very familiar with, even if you don't recognize it right away. 2 length plus 2 width. Remember, it doesn't matter what order you add and multiply in. So it just has 2 width times 2 length. But the same thing, we know what our perimeter is because we only have 112 feet of fencing. Can't be more, can't be less. 112. The width is the unknown amount. An unknown you represent with a variable, x, easiest one to represent. The length has to be 3 times that much, 3 times that same x. So now in place of each of these boxes, we can sub in our numbers. So in place of perimeter, we put 112. In place of width, we can put x. In place of length, we can put 3x, and that's what they have on the next line. So 112 is equal to 2 times x plus 2 times 3x. So multiply next. 2 times x gives you 2x. 2 times 3x gives you 6x. So now you have something that simply says 112 is equal to 2x plus 6x. Those are 2 like terms you can combine. You can combine 2x and 6x and get 8x. So 112 is equal to 8x. And then we know how to get x by itself. We divide each side by 8. And when you divide each side by 8, x's value is 14. So again, going back to the picture from a second ago, which one is going to be 14, the length or the width? Which one is simply represented by x? The width is. So the width will be 14 feet, and the length will be 3 times that 14 feet, which is 42 feet. So again, your picture of your dog pen would look like this. These would be 14, and these two would be 42 on your picture according to your length and your width. Okay, on the back, you don't have to copy this scenario down, but I want you to draw a picture to mimic what is going on. It says a page of pictures for yearbook. So picture, opening up a yearbook and seeing pictures on it, is 8.5 inches by 11 inches. So the whole page is 8.5 by 11. That's a typical size page. The top margin, you know what that is 3/4 of an inch. And the bottom margin is 1.25 inches. The space between the pictures, between each picture, is 3/16 of an inch. How high can each picture be to fit 7 down the length of the page? So there will be 7 pictures. So draw a picture to mimic this situation, and then we'll talk about how to determine the size of the pictures once we have the picture drawn. Take about a minute to draw this picture. Look at it again if you need to see one of the values. So the first thing, your picture is going to look like this. Did anybody draw it in landscape form? Did anybody draw it on its side? Because it did not specify that in the description. We're all on the same page and we all drew it looking like a book. Okay, so the first thing you have is 8.5 by 11. So it's going to be 8.5 across by 11 inches, the outside of the book. Okay. It said the top margin, that's this portion here, is 3/4 of an inch. The bottom margin, that's this portion here, is 1.25 inches. Then it says the space between the pictures is 3/16 of an inch. How high can they be to have 7 pictures down the length of the page? So 7 pictures is what you need now. 1 picture, 2 pictures, 3 pictures, 4, 5, 6. And again, you don't have to be an artist, everybody. 7. That is 7 pictures right there. That's what you should have, something that looks like that. It tells you the space between each of the pictures, though. So each one of these spaces here, this one, this one, this one, this one, this one, and this one, all together, there are 6 of them. The space between each of those pictures is 3/16. And again, there are 6 of them. What do we know about the height of the pictures? Do we know how much it is? No. So how do we represent something we don't know how much it is? X. So we know that we have 7 of them, and it's times an unknown amount. So this picture right here represents all of the numbers that we need to determine how big each picture can be. Okay, first off, what number up there is completely unnecessary? What number do you not use? We're looking for the height of each picture. Do we want to know anything about the width of each picture? No. So what number represents the width on the page? 8.5. So that number, even though it's there, is unused in this problem. So that's the first thing you could do is eliminate that number because you don't use it. Now, the whole thing, now that we have our picture drawn, we don't need the description anymore. We're just going to use the picture. The whole thing is equal to 11. So now all we need to do is put everything else together. 3/4 plus, I'm going to just do the margins, 1.25 plus 6 times 3/16. Those are the spaces. Plus 7 times x. All of that put together is equal to 11 inches. Remember, multiplication comes first when you're simplifying, so let's simplify this. The number 2 goes into both of these, into this one 3 times, into this one 8 times. 3 times 3 is 9, 1 times 8 is 8. Let's simplify this. Let's make that into an improper fraction. 4 times 1 is 4, plus 1 is 5 over 4. Positive 9 over 8, positive 3/4, plus, and I know we all hate fractions, myself included. Y'all are not alone. We all hate fractions, but we're going to get rid of fractions right here. Let me show you how. What is the least common denominator of 4, 8, and 1? Remember, least common denominators are not numbers that go into them. It's numbers that they go into. 8, always try the biggest one. 4 goes into 8, and so does 1. So the way we're going to get rid of, instead of adding them all up, instead of adding every one of them up and changing them all and making them into the same common denominator, let's multiply all of them times the number 8. That times 8, this times 8, this times 8, this times 8, and this times 8. Remember, multiply every term in the equation times 8, each term. 8 divided by 8 will cancel those two out and just simply leave you with plus 9 right there. Okay. 8 doesn't cancel that out at all with the 7x, so it'll be plus 56x. Everybody know why I wrote 56x right there? Okay. 4 cancels out 8, but not all the way. 4 goes into itself once and into 8 2 times. So 5 times 2 is positive 10 right there. And also right here, it goes into itself once and into 8 2 times. So 3 times 2 is positive 6 equals 8 times 11 is 88. So now we're dealing with numbers that are much larger than they were a second ago, but the fractions are gone, and we all appreciate when the fractions are gone. So now it's a simple equation. Combine all of your like terms. What numbers can I put together? 6, 10, and what? 9. So 6 and 10 is 16, plus 9 is 25. So all of those together are 25 plus 56x. Notice how nice this is coming together. Is equal to 88. What do I do first to undo this problem? We want to get x by itself. So we get rid of positive 25 by subtracting it. If you subtract it there, subtract it here. 8 minus 5 is 3. 8 minus 2 is 6. So 63 equals 56x. How do I get x by itself now? Divide by what? What do I do to the other side? The same thing, divide by 56. And we're going to use a decimal equivalent to make this easier. X is equal to 1.125, or x is equal to 1.125. So in the picture, we just said that x equals 1.125. In the picture, what is 1.125 inches? Each what? Each picture is 1.125 inches. Notice there is a lot involved in that problem, but once you get it into an equation, if it weren't for the fractions, it would be a very simple equation to find out how big each picture can be. Number 2 is using a graph as a check. Sarah and Jim both decide to save money each week. Sarah has already saved $100, and she plans to save $10 a week. $10 a week, or $10 per week. Jim plans to save $15 a week. In how many weeks will Jim and Sarah have the same amount? So it says first write an expression for Sarah's money. She has 100. Plus, she's going to save $10 a week. So 10 per week. When will that be equal to what Jim has? Jim has. It didn't say Jim had any to start with. So Jim's going to save $15 per week. This is our equation. 100 plus 10x equals 15x. We want to collect our x's on the same side. So move the smaller 10x over to the bigger 15x. It's positive, so subtract it. If you subtract the left, subtract the right. What is 10x minus 15x minus 10x? So we have 100 equals 5x. How do we get x by itself? Divide by 5. We do it to the right, do it to the left. In how many weeks will they have the same amount? In 20 weeks. Sarah and Jim will have the same amount in 20 weeks. Okay, here's your verbal model just to go through it real quick. Sarah's original amount plus the amount she's going to save each week times the number of weeks, that's the unknown amount, is equal to how much Jim's going to save each week times the number of unknown amount. So Sarah's original amount, 100, 10 for each week. X is the amount of weeks. That's Sarah's. Jim is 15 each week. There's your algebraic model I wrote a second ago. 100 plus 10x equals 15x. Move your x's all to the same side by subtracting 10x. 100 equals 5x. Divide by 5 on each side. X is equal to 20 weeks. Jim and Sarah will have the same amount saved in 20 weeks. The graph of it says use a graph to check it. If you graph those by plugging in those 2 points, you're going to intersect them at this point here. And we'll get to graphing equations later on. But when you make a table to graph this, they're going to intersect at 20 weeks. You have 78 feet of fencing to enclose a rectangular pen for your rabbit. Rectangular pen. Remember, draw a picture. Rectangle. 78 feet all the way around. To provide sufficient space, the pen has to be twice as long as it is wide. You got to know what this means, everybody. Twice as long. So the width is unknown. The length is 2 times that unknown. You got to understand that. If you don't understand that, come see me after class, and I'll get you some tutoring. So your perimeter, P, is equal to 2 length times 2 width. Perimeter, we know, is 78. That's all we got. So in place of perimeter, 78 equals 2 times your length. What is our length according to the picture? 2x. Plus 2 times the width. What's our width according to the picture? No. What is our width? Simply x. So 2 times 2x is 4x plus 2x equals 78. Combine your like terms, 4x and 2x. 6x equals 78. And in order to get x by itself, divide by 6. It goes into 7 once. And there is 1 left over. It goes into 18 3 times. So the width of your rabbit's pen is 13. What is the length of the pen? So this one is 13. What is the length? 26. Tells you to find the dimensions. Your width is 13 and your length is 26.